So moving on to the third bit, which is x power 4 plus 3x cube plus 3x square plus x plus 1. So I can write p of x is equal to x power 4 plus 3x cube plus 3x square plus x plus 1. So by using the factor theorem, we can find x plus 1 is the factor of the given polynomial or not. So x plus 1 is equal to 0 and x is equal to minus 1 is the 0 of the given polynomial. So we can substitute p of minus 1 is equal to minus 1 whole power 4 plus 3 times of minus 1 cube plus 3 times of minus 1 square plus of minus 1 plus 1. This gives 1 plus 3 times of minus 1 plus 3 times of plus 1 minus 1 plus 1. Minus 1 and plus 1 gets cancelled. This gives 1 minus 3 plus 3. Minus 3 and plus 3 cancel and this gives 1, which is not equal to 0. P of minus 1 is not equal to 0. Therefore, x plus 1 is not a factor of the given polynomial. Coming to the fourth bit, which is p of x is equal to x cube minus x square minus 2 plus root 2 times of x plus root 2. So the 0 of the polynomial would become x is equal to minus 1. So substituting x is equal to minus 1 in the given polynomial, we will be getting minus 1 whole cube minus minus 1 whole square minus 2 plus root 2 times of minus 1 plus root 2. So this becomes minus 1 minus 1 plus 2 plus root 2 plus root 2. We'll be getting minus 2 plus 2 plus root 2 plus root 2. Minus 2 and plus 2 gets cancelled. Root 2 plus root 2 is 2 root 2, which is not equal to 0. Therefore, by factor theorem, we can say that x plus 1 is not a factor of the given polynomial. Coming to the first problem, determine which of the following polynomials has x plus 1 a factor. The first polynomial given to us is x cube plus x square plus x plus 1, and the second polynomial is x power 4 plus x cube plus x square plus x plus 1. So in order to find the solution of this problem, we need to make use of factor theorem. So the factor theorem states that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. So this is the factor theorem. By using this factor theorem, let us determine x plus 1 is a factor of the given polynomials or not. So the first polynomial is given as x cube plus x square plus x plus 1. So we can write it as p of x is equal to x cube plus x square plus x plus 1. And the given linear polynomial is x plus 1. So first equate the given linear polynomial x plus 1 is equal to 0. So we get x is equal to minus 1, which is a 0 of the polynomial. Now let us substitute minus 1 in the place of x. We get p of minus 1 is equal to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So we get minus 1 whole cube is minus 1 and minus 1 whole square is 1. This is minus 1 plus 1 which gives 0. That becomes P of minus 1 is equal to 0. By our factor theorem, we can say that x plus 1 is a factor of the polynomial x cube plus x square plus x plus 1. Now coming to the second problem, which is x power 4 plus x cube plus x square plus x plus 1. We can write it as p of x is equal to the given polynomial x power 4 plus x cube plus x square plus x plus 1. And the 0 of the polynomial we have obtained it already by x plus 1 is equal to 0 and x is equal to minus 1. So let us substitute x is equal to minus 1. That is p of minus 1 is equal to minus 1 power 4 plus minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. This gives 1 minus 1 plus 1 minus 1 plus 1. So this gives plus 1 and minus 1 gets cancelled, minus 1 and plus 1 gets cancelled. Finally we will be getting plus 1. So p of minus 1 is equal to 1, which is not equal to 0. Therefore, by factor theorem, we can say that x plus 1 is not a factor, since p of minus 1 is not equal to 0.